Hello everyone and welcome to On the Spot STEM. Today we'll be covering 2019 Aime I problem number 7. The problem reads, there are positive integers x and y that satisfy the system of equations log base 10 of x plus 2 log base 10 of GCD x and y is equal to 60 and log base 10 of y plus 2 log 10 log base 10 of LCM of x and y is equal to 570. Let m be the number of not necessarily distinct prime factors in the prime factorization of x, and let n be the number of not necessarily distinct prime factors in the prime factorization of y. Find 3m plus 2n. So at first sight, we see that this is a problem involving logarithms. So a common trick on the Aime is that when one sees logarithms, to try to get rid of them as soon as possible. And so we can do that using substitutions by subbing x is equal to b to the a, where b is the base of the log that is being taken of x. So we involve that trick over here. So we let x equals 10 to the a, and y is equal to 10 to the b. And since this is only number 7, we're assuming that a and b are going to be positive integers, because log problems that appear in the first half of the Aime are usually pretty simple to figure out, and they have if you make these kinds of substitutions, then they usually come out pretty nicely. And if this substitution does not work out, we can always go back and try to find another way to solve the problem. So plugging these into the equation gives that log base 10 of 10 to the a is equal to a plus 2 log 10 of GCD x and y. So how do we represent GCD x and y? Well, GCD of x and y is simply equal to GCD of 10 to the a and 10 to the b. And we're assuming that a and b are positive integers here, and if this doesn't work out, then we can try another method. But if they are positive integers, then the GCD of this is simply equal to math.min, or 10 to the power of min of a and b. So plugging that in here as GCD x of y, we get that plus 2 log base 10 of 10 to the min a and b, which is just 2 times min of a and b. And this is equal to 60. Now we see that b plus 2 log base 10 of LCM of x and y is equal to 570. Well, the LCM of x and y is equal to the LCM of 10 to the a and 10 to the b. If a and b are both positive integers, this is simply equal to 10 to the max of a and b. So it's equal to either 10 to the a or 10 to the b. So b plus 2 max ab is equal to 570. Now we can do cases on what min ab is and what max ab is. Well, we see that if we set min ab is equal to a, this makes a lot of sense since the equation involving 60 has a inside it, and the equation involving a much larger number, which is 570, has b inside it. So it makes intuitive sense to set min ab equals a and min max ab equals b. Then a plus 2 times a is equal to 60, and b plus 2 times b is equal to 570. The first equation gives us a is equal to 20, and the second equation gives us b is equal to 190. Thus, x is equal to 10 to the 20, because that's 10 to the a, and y is equal to 10 to the 190. As a brief kind of security, we can just plug these into our equation. Log base 10 of 10 to the 20 is 20, plus 2 times log base 10 of GCD of 10 to the 20 and 10 to the 190. GCD of these two is equal to 10 to the 20, so plus 2 log base 10 of 10 to the 20 is equal to 40, plus 20 is 60, which makes sense. Log base 10 of 10 to the 190 plus 2 log base 10 of LCM of x and y, which is 10 to the 190, is equal to log 190 plus 2 times 190, which is 570. Thus, x is equal to 10 to the 20 and y is equal to 10 to the 190. Now it says let m be the number of not necessarily distinct prime factors in the prime factorization of x, and n be the number of not necessarily distinct prime factors in the prime factorization of y. So x is 10 to the 20, so that's equal to 2 to the 20 times 5 to the 20. And there are 22s in here and 25s in here. So there's 40 total prime factors. So that's equal to m. For n, it's equal to 2 to the 190 times 5 to the 190. There is 190 plus 190 equals 380 total prime factors, and that's equal to n. So we want to find 3n plus 2n, which is equal to 3 times 40 plus 2 times 380. This comes out to be 120 plus 760, and that is equal to 880. So we find 3m plus 2n equals 880. Scanning over the problem again, we see that there's nothing else that is being asked, so we can put down 880 and we are done. Thank you for watching. If you like this video, please subscribe and share with your friends. Thank you.